A very good morning to everyone. My name is Bubrajit Sanam Ganesan and I'm from DEP4A. My metro number is 10DEP19F1038. And here I'm going to tell the procedures about soldering the PCB layout. Alright, with a bit knowledge about the PCB soldering is, what the various techniques are and what tools are necessary for the job. Let's now take a closer look at how to solder PCB board in simple, easy to follow steps. First of all, prepare our iron. Before we can use an iron to solder, we want to complete process knowing tining. This process is all about coating the tip of the iron in solder to aid in the heat transfer process. Begin this process by winding up the iron thoroughly and letting it rest until it reaches in full heat. Once it has completely heated, coat the tip thoroughly with solder, making sure to cover the entire tip. We'll need to use plenty of solder to do so, and some of these will likely drip. Be prepared for this. Once we are certain the entire tip is coated, wipe it off with a wet sponge to get rid of any excess flux residues. Do this right away, or else the flux may have time to solidify on the tip and become difficult to remove later. The second procedure will be prepare the surface. The key to a good soldering job is to start with a clean surface. To ensure our PCB board is clean and ready for soldering, use an industrial cleaning pad to wipe the surface clear of any dust and debris. We may also use an acetone cleaner to give it an additional wipe down. Finally, we might try giving it a few blasts of compressed air, as this will remove any small particles stuck in the board. Third procedures. Place the components. Unless we are working with an exceptionally simple circuit board, we'll likely only be soldering one or two components at once, as opposed to doing the entire board is one season. I recommend starting with the smaller pieces and working up to the larger ones. This helps keeping the board flat and balanced as the process begins, rather than weighting it down on one side with a single heavy piece. Begin by selecting a few small components and placing them where they belong on the board. Bend the leads as we find that we need to and insert the components into the holes where they belong. If you are having trouble getting the piece to stay still once we aren't holding it in place, try bending the leads so that they rest at a 45-degree angle along the bottom of the board. The fourth procedure is apply some heat. Add a very small amount of solder to the tip of the iron. This isn't the solder that's going to hold the components in place, but is rather intended to conduct heat from the iron to be bored. To properly heat the joint, hold the iron so the tip touches both the board and the component lid. This positioning is critical since if the tip is in contact with only one of these pieces, the solder won't stick. Once the tip is in position, the solder we need to apply earlier will make contact with the both lid and the board, heating them up and preparing them for the soldering. Hold the iron in position for a few moments before removing it. And also, it's possible to overheat during the stage, which we'll want to avoid. If we notice the area starting to bubble, remove the heat immediately. Wait for it to cool and then heat it again, more cautiously this time. The fifth procedure is add solder to the joint. Once we have heated the joint, we are ready to solder. Begin by touching the tip of a strand on solder to the solder pad and lid. If you have heated this space correctly, the solder should flow freely and the flux should begin to liquefy and bubble. Keep adding solder around this joint until it's entirely coated. forming a small moon. When we have reached this point, stop adding solder and remove our iron from the area, setting it aside. As the joint cools, make sure it stays absolutely still. If we just it or allow it to move, the finish will look dull and grainy. At last, the last procedure is finish up. Once the joint has finished cooling, conduct a small inspection of it. If the solder joint looks good, move on to trimming the lid. We'll do this by using side cutters to cut at the very top of the joint. From here, move on the move on to the next component that we want to solder in place. Once we are finished with all our soldering for our current section, make sure to clean up any extra flux from the board, leaving that with a clean and finished product. And that's all for soldering procedures, guys. Thank you very much. And now I'm going to tell about the procedures on how to etch a PCB. First of all, we need to design. The first procedure will be design. We need to design the board using a service like Eagle, Freezing, or we can even just use Adobe Illustrator if we know exactly what we want. And remember to flip the design once we have it complete before we print it out. The second procedure is print it out the design onto the shiny side of the transfer paper. The third step will be sand the copper plate so there is a rough surface for the design to stick to when transferred. Starting from this point on, we should use surgical gloves to handle the copper plate and etching solution. This helps avoid getting oils on the copper and chemicals on our hands when sanding to an extra good job on the edges. The fourth step is wash the copper with some water and rubbing alcohol and let it dry. The fifth step is cut out the design and place them face down on the copper. In this part, we should try and have some margins around the design. This also helps the ink stick to the plate. The step 6 will be run the copper plate with the design face down through a laminator 5 to 7 times until the plate is hot. In this part, we can also use an iron instead of laminator if we don't have one. Step 7. After running the plate through a laminator or iron, place the plate into a cold bath and agitate until the paper floats off. The eighth step is place the PCB into the etching solution and aggregate for 25 to 30 minutes or until all the copper has dissolved around the design. If we would prefer not to aggregate by hand, here is another instructable I should create it on how to make an aggregator using an old CD-ROM drive. Step 9. Once all the copper is gone, rinse it in the water bath, let it dry and use rubbing alcohol to whip off the ink transferred onto the PCB. Step 10. And now we have to etch PCB board, but we still need to drill the holes. The best way to drill the holes out of the PCB board is to use a Dremel, a 1/32-inch drill bit, and it would be best to use a Dremel press, but if we can't do that, we can clamp down the Dremel and bring the board to the Dremel by hand to drill the holes. And that's all, guys. Thank you so much. And this would be the circuit that given by my lecturer to create it, and I've created it in my own. Then this would be the PCB layout. There's no CRC errors and no DRC errors. And last, 3D visualizer. in here is and the back one. And thank you so much.